Hello everyone and welcome back to another British Informatics Olympiad video. Today we'll be taking a look at the 2015 paper and we'll be taking a look at the second question. So let's have a look at the question. I've highlighted the important parts as always, and feel free to pause the video and just have a read before I then explain the code for this. Okay. So with this particular question, it's like the challenge is more the implementation rather than the algorithm, since the algorithm is quite straightforward as to what exactly we have to do, since the question has explicitly spelled it out for us over here that we must follow these 5 steps. And then one more challenge inside this is actually finding some sort of suitable representation for each of these ships within the grid. And now, with those two main parts of the question in mind, let's have a look at the solution. Okay, so I started by creating this class game, and we initialized these two particular things. So first of all, the values of A, C, M, and R, since these are just input, so we might as well just take them as input towards the class and initialize them. And we also have this grid. So this grid represents the 10 by 10 grid, and the reason why I have true for all of them is because how I will denote whether a cell has been occupied or not is by a Boolean value, true or false. True means that the cell is free, and false means that the cell is occupied, so it's not free. Okay, so that's the initialization, and now we have this translate. So what this does is pretty much our function, this particular calculate function, and the algorithm, as it states, takes in some xy and outputs the xy. And these xy are both in Cartesian form, like the regular coordinate system. But then, if you have previous experience with these sorts of questions, you'll know that we can't reference elements inside the grid the same way as we would in Cartesian form. So if we just go back to the question, this problem will become quite clear. Pretty much, the question states that the bottom left corner is 0, 0. So the bottom left is 0, 0. However, for this particular value inside inside the grid, this would be, it would have a row value of 4, since indexing starts from 0, and a column value of 0. So 0, 0 is not the same as 4, 0, so we can't just use the same sort of coordinate. We need some sort of translation function between Cartesian and the coordinates which we can reference our array index 6 by. So now let's go back to the code, which is why we have this translate. So what this does is it returns 9 minus the second value of the coordinates, and then returns back the first value. So if you're not quite sure as to why, I won't explain it that much now, but we'll just try it with a few values, like on pen and paper, and then, yeah, so it will make sense pretty quickly, trust me. And now this is the calculate function. So this is the function which we use to actually implement the 5-line algorithm which they told us. So if we go back to the question, initially the very first part of the algorithm is we set r equal to a times r plus c, and then in some mod m. Okay, so we do exactly that inside the code. If we go back to the code, we set r to equal a times r plus c mod m. And then the next part is we use the units digit of r as the x-coordinate and the tens digit as the y-coordinate. So then we pretty much just x equals converting r into a string and then taking -1. So what -1 is -1 is the basically the last index. So the last index would be the units digit, and then that becomes the x-coordinate. And then if r is greater than 10, if r is less than 10, then the tens digit will be 0. But if r is greater than 10, then it's basically just the final, the y-coordinate is the tens digit. And then the way we decided the tens digit is we took r mod 100 and then divided it by 10. We could have also done int string self to r, and then instead of -1, if we had 0, then that would have also worked just fine. And now we basically just go if r is even, i.e. if r is equivalent to 0 mod 2, then the orientation is h, i.e. horizontal, and if r is odd, then the orientation is vertical. Okay, and then we return the two coordinates x and y as well as the orientation. Okay, and now that's basically exactly what we were told to do inside this algorithm. And now everything else which you'll see is just all the other things surrounding this algorithm, which determine like how exactly we can do it. So if you remember in the question, one big part was determining the validity of a particular ship's placement. And now if you remember, a ship's placement is only valid if none of the adjacent squares within the occupied squares for the ship are already taken. And now the way we decide this is, if the orientation is horizontal, then for c in range, col plus length, this iterates through every column value. And then for I in range -1 to 1 and j in range -1 to 1. So what this does is this checks the 9 squares surrounding a particular square, and then this repeats this for all column values. And now if rho plus I and c plus j are both within the limits, i.e. if it's a valid square on the board, then if that particular cell is occupied, i.e. if this is false, which means not this is true, then we need to return false, because that means that a particular adjacent square is occupied. And then otherwise, if they're both 0, then we also return false. Now, the reason for this is because if both of them are 0, then like it has to have been occupied, since it's not if I and j are both 0, then it's the row and column value itself which is there, and then that one needs to be returned false anyway, basically. And now for determining the validity of the vertical, we do a similar process. We start by the row value, and then we go row minus length, because remember, we basically place the ships vertically upwards. So then we start by row value here, and then we go up, since if you remember back to the 2D coordinate system, that's how like internally the row and column values are basically stored. And then we iterate backwards, so we have -1 here. Then we do the exact same procedure, and then returning false and returning false in these two cases. And then if it has not already returned false in all of these particular cases, then we finally return true. This means that this particular orientation is indeed valid. Okay, so that's the valid function and the calculate function. And now we just have the place function. So what this does is, it basically it takes the row and column value after translating the coordinates, and then for each of the if the orientation is horizontal, then for each of the column values from the original column value and then the column plus length value, i.e. the final value, we set that particular value to false, and then we repeat the exact same procedure. If it's placed vertically, we set all of the necessary squares to equal false. And now we have this move. So what this move does is, this basically carries out one move, and it determines if the place is not false. If the place is false, sorry, then that's basically determining whether that particular battleship has been placed or not. And while the battleship is not placed, then we do the calculation of the coordinates and the orientation, and then placed is the Boolean value returned by the valid function. And then as soon as the placed is true, then we'll break out of this while loop, since this condition will no longer be true anymore, and then we'll place this, okay? And then we just, all we need to do is return the coordinates and the orientation. And now notice, the only relevant part to determining the move is the length of the battleship, since this is either 1, 2, 2, 3, or 4, okay? And now we just have this play function which puts everything together. So we have this order, we place the 4 1 first, and the 2 3s, and 3 2s, etc. And then for length in order, just iterating through every possible length. We basically set the coordinates and orientation equal to whatever the return value of the move function is. And then we just return the first position value of the coordinates, i.e. the x value, and then the y value, and then the orientation of where each one was finally placed. And then we just output this, basically. And the output is basically just outputting the grid exactly in order, and this is just more of a like helpful tool in debugging, rather than an actual use of the question, but it's there anyway, so yeah. Okay, so now let's see if our code actually does work. So this is basically the input, and now if we go back here, as you can see, there's the output, and now let's just compare line by line. As we can see, this is indeed correct. And maybe let's test it on one more from the mark scheme. Let's give it the final test case, maybe. So this is the value, and now let's just compare. So first of all of them are vertical. Now 909676, 9096 and 76, 725058, yep, does indeed look to be correct. So that's pretty much it for this particular video. I really hope you enjoyed watching the video. Hopefully you learned something new about, maybe it was about how we represented the internal coordinates and how we nicely organized every part of this question into one class. If you did enjoy the video, please be sure to leave a like and subscribe. Also, if you would like to check out the code at any time, feel free to visit my GitHub, where you can find all the codes for all of these British Informatics Olympiad questions. And I hope to see you in another video next time. Thank you very much for watching. Bye.